Hello, everyone. Thank you for joining me today, this afternoon, this morning, or even late at night. I don't know about you, but we are having a beautiful Thursday morning here in Watertown, South Dakota. I'm Amelia Thompson, your host of our Wurth Electronic webinars, and we are very excited about today's webinar. Joining me is our presenter, Hero Bustos. I hope I am pronouncing that correct, Hero. Today, he will be presenting Lan on Command. Now, Hero is a product management for signals and communication at Würth Elektronik in Waldenburg, Germany. Now, after Lan on Command, you will be receiving Lan on Demand because you registered for today's event. You will automatically receive the follow-up email, including the presentation, within the next 24 to 48 hours. If you have any questions during today's webinar, make sure you are asking them in the questions box, and our presenter will answer them at the end. Don't forget to register for our next webinar coming up next week. It's We Cut the Cord, Wireless Power Transfer with Chem Sum on May 12th. That is Wednesday, May 12th at 9 a.m. Central. And of course, this is free, all thanks to our exclusive sponsor over at Digikey Electronics in Thief River Falls, Minnesota. You can find all of our webinars online. Register today at www.we-online.com/webinars. Now I'll pass it over to Hero Bustos presenting Lan on Command.
Thank you, Amelia. Thank you for the presentation, and thank you all of you for attending today's webinar. So I'm gonna go ahead and I'm gonna shut off my camera so that we don't have any issues with the transfer of the images. And yeah, if you have any questions, I'm very glad to answer them at the end, as my colleague Amelia already told you. So today's agenda, I would like to go a little bit into the industrial Ethernet development, since it has been, developing in the past few years. I would like to go into the explanation of what is a LAN transformer for those of you who are not very familiar with this kind of product, and what kind of parameters we find when we talk about LAN transformers. Other than that, I would like to also give you an insight into the power over Ethernet and other type of applications in which our LAN transformers can be designed into. And finally, I would also like to show you what kind of sexy articles we have in the development roadmap for the coming years, or what we've been doing also in the past few months and years. So as I said before, I would like to give you an insight in the industrial Ethernet. So there's a lot of type of buses and systems that we can use in the industry, but mainly we have seen that the industrial Ethernet has been gaining a lot of power in the last few years. So here we can see that from 2016 to 2019, the industrial Ethernet grew from 38% to 59%. So that was an annual growth of 20%. So as you can imagine, this gives us a lot of possibilities to expand our LAN transformer business, and also to support you guys in all of your new designs. So going into what is a LAN transformer, I would like to first of all explain what is a LAN network. LAN network is a local area network. These kind of networks can be found in hospitals or companies or even at your home. So basically what we have is the backbone, the Ethernet backbone, and then we have different components, different systems, different devices connected to this network. And all of them can be communicating with each other. So in an industrial area, we can see here we have some back office servers or data servers, which will be accessed from the different components or the different devices or computers inside the factory. We also have robots, for example, or other sensors, which will be connected to the Ethernet network. And for all of these devices that are connected to an Ethernet network, we need to have a LAN transformer. We will see later on why we need a LAN transformer, but just bear in mind, for every kind of device that will be connected to a network, LAN network will need definitely a LAN transformer in it. At Würth Electronic ISOs, we have different types of LAN transformers. We have a very wide portfolio. So we have from 1000 base T to 1000 base T up to 10 gigabit base T even. We also offer PoE and non-PoE articles. So yeah, basically what we can see here is the different sizes and the different housing factors or forms. As we can see here, this is a small one, 100 base T L form. L form is coming from the type of pin that we have here. Then we also have the gull wings. So the gull wing has basically an inner layer of pins here where the wires are being wounded. The wires from the cores here are being wounded too. We have also 10 gigabits, and also you can see here the cores of the transformer here are pretty thick. That's due to the PoE capacity of this transformer. We also have very low profile, so up to between 2 and 3 millimeters of height. So for those devices that are pretty thin, we also have transformers that do actually fit in those. And we also offer a series of high voltage transformers for medical applications, for example. In terms of RG45s, we also have a very wide portfolio here. So we can have, we can offer you guys a tab up or a tab down. We can have with shielding tabs or without shielding tabs with LEDs. The LEDs can also be bicolor, so 2 colors on the same LED if you want to have that. We have THT and SMD. And we also even have some of those RG45s with USB connectors integrated. So you can see here on the left-hand side, that's a 2.0, and on the right-hand side, we have a 3.0 USB port. We also offer stacked RG45s, so 4x4, 2x2, 1x2, 1x4, whatever. So if you need those, we also can support you guys there. So basically what I would like to show with this slide here is how is the communication working when we have a 100 base T or when we have a 1000 base T. So basically for 1000 base T, we only use 2 of the 4 pairs in the Ethernet cable. So if you guys know, the Ethernet cable has 4 pairs, 8 wires, they are paired up in 2s. And for 1000 base T, as I was saying, we only need 2 of those pairs. The communication here will follow in unidirectional way. So on one of the channels, we will have a transmission, and on the other channel, we will have the reception of the information. And these channels here will not be working bidirectionally. Whereas on the 1000 base T or even the 10 gigabit, we have all 4 channels in use, and all channels are working bidirectionally, as you can see here, represented by the arrows going in both directions. So by multiplying by 2 the number of channels that we use, and also using the bidirectional communication of the information, we manage to achieve the 100 base T data rate. Also, the kind of signals that are transferred here are also different, but that goes too much into depth, and I don't think that's the scope of today. So here you can see what is composing a LAN transformer. Basically, the basic unit of a LAN transformer is the transformer itself. So we call it pulse transformer. It's a pulse transformer because it manages pulse signals, so square signals. Ethernet signals are square signals. And it is a one-to-one transformer. So there is no kind of transformation of the signal. So whatever I have on one side of the transformer, I will have identically on the other side of the transformer. Now, it is very recommended to have a common mode choke included in the LAN transformer, only for the purpose of rejecting any common mode noise that can be coming from the cable into my device. Of course, we can also have an extra common mode choke here. I will go into that again later on. That's called HPLE transformers. We call them HPLE, so high performance, low EMI. And we can also have auto transformers on this side here. Now, why do we need, or where can we need an auto transformer on the LAN transformer? If you guys know, there is, we will see that also later on in one of the schematics, there is a Bob Smith termination. This is a network of 4 75 ohm resistors, and this network of resistors needs 1 pin to be attached to. So on one side, it will be attached to ground, and on the other side, it will be attached to 1 pin on the transformer. Now, this transformer offers the pin here in the middle, And if we have a common mode choke on this side here, we don't have a center tap here for this bottom termination. So where should I connect it to? If I connect it directly to the center tap of the transformer, I can have any of the noise generated in this network resistor network can be transferred to the other side of the transformer. And I don't want to have this. So I get an auto transformer here, which provides me with a center tap here where I can connect my bottom termination. And the auto transformer will work exactly the same. I'm just going to jump a few slides and I'm going to show you that. The auto transformer will work exactly the same as a common mode choke. So as you can see here, if we have a differential signal, the differential signal will create the same polarity, so a high impedance, and the differential signal will go through the auto transformer, which is what I want because my Ethernet signals are differential signals. As opposed to if I have a common mode signal, which will generate the same polarity, the opposite polarity, creating a low impedance for the common mode signal to go down to ground. Now, okay, here it is. So as I was saying, the basic unit that I need in a Lan transformer is the transformer itself, because I need to have an isolation. So the IEEE 802.3, which refers to the 62368 from IEC, or the old 60950 from IEC as well, requires a 1.5 kV isolation between the phi and the cable. So that's what I'm going to have with my transformer, and also between the shielding and the cable and the cable. Okay, so basically the shield here of the RG45 will be connected to ground, and also this side of the cable here with the phi chip side will also be isolated with 1.5 kVs. Now, there is another standard, the 60601, for example, which also requires up to 4 kV voltage isolation. This is for medical devices. This standard is for medical devices, but there are also different applications which can also require a higher isolation voltage as the 1.5 kVs. And we also offer them as well. Okay. So going into the parameters of the Lan transformers here, we can see how more or less one of the data sheets of a Lan transformer looks like. We have different parameters, different frequency ranges, different test conditions you can see here. So basically this one here, which goes up or defines the parameters up to 100 megahertz, applies for a 10,100,000 base T transformer. Since for 10 gigabit transformers, we need a better performance up to the range of 500 megahertz. Basically, the open circuit inductance, which we specify here as 350 microhenries, this is the inductance that the phi chip needs to see in order to be able to work properly. We do actually have some of those transformers that don't have the 350 microhenries minimum. Reason being is the 350 microhenries minimum requirement is for 1000 base T. Up from 1000 base T and upwards, so for 10 gigabit, for example, there is no specific value in the IEEE 802.3 standard. It will be referred to the, so it refers to the droop of the transformer. And of course, the inductance value plays a role here. But we have the experience that with 120, even 150 microhenries, the phi chips work fine. So that's not a big issue if you see a transformer with no 350 microhenries minimum inductance. The insertion loss and the return loss, without going into much detail, it will basically tell me how the transformer is affecting my signal. So basically what I want to do is I want to have on my cable, the signal that I have on my cable transferred to my phi chip. Now the insertion loss will let me know how much of that signal is coming actually through. As you know, we live in a real world, and not all of the energy of the signal will be transferred from one side to the other side. And by looking at the insertion loss, I will see how much of that signal amount is passing on from one side to the other side of the transformer. On the other side, I have the return loss, which will tell me how much of my signal is being reflected backwards. So due to perhaps mismatch, impedance mismatch. Basically, I want my insertion loss to be as small as possible. So I want it to be across or along 0. Yeah, was away, was gone. Okay, so I'm back. Sorry for that. We also have 3 other parameters. That is the differential to common mode rejection ratio and the common mode rejection ratio. These two parameters will let me know how my signal is affected in terms of how much common mode noise am I having, or how much of my differential signal is being actually converted into a common mode signal. So the differential to common mode reaction ratio will tell me how much of the differential energy that I have is being actually converted into a common mode signal. And my common mode rejection ratio will tell me how much of the common mode that I am having in my cable is being rejected. Okay, so as you can imagine, I want these values also to be as big as possible. And the crosstalk is something that, you know, if you have a neighbor channel, you saw before in the slides before that those cores inside the housing are pretty fit together. So the magnetic fields generated around the cores will definitely affect the neighbors. So here you can see that I have my signal of interest on one of my channels, and some of that is being transferred also on the neighbor channel. And this is something that I don't want to happen. So by measuring the crosstalk, I can see how much of my energy is being coupled in my neighbors. Now, power over Ethernet is a very, very, very nice property of Ethernet. So basically what we can do here is provide some devices with voltage and current, so with power, so that they can work without the necessity of having a power cord. So for example, if you can imagine one of these IP cameras set up out on one of, you know, a building for a company, if you need to have the power cord and then also the Ethernet, then you have to have 2 cables, and that's, you know, more costs, also more work. So yeah, so power over Ethernet gives you the possibility of passing electrical power along the same cable. Now, if we recall the 1000 base T application, where we only use 2 of the 4 cables, or sorry, 2 of the 4 pairs of the Ethernet cable, we can have 2 pairs for the data and the other 2 spare pairs for the PoE current. Or we can also use the data lines with current. For 1000 base T, we have no possibility of using spare pairs because we use up all of the 4 pairs. And since 1 year, 2 years ago, we have a new standard on the market from IEEE 802.3. That's the BT standard with 4-pair power over Ethernet, which kind of standardizes how the power should be transferred when we want to use all 4 pairs. So here we can see how the power is going to be transferred. So I have a PSC, so I have my power sourcing equipment with my cable, which will provide me the current. The current will come in through the 2 wires, or the signal wires of the transformer in this case, and they will join up in the center of the transformer, being transferred into my PD, so my powered device. In this case, maybe a camera or an IP telephone. In order to go back, we need a closed loop for DC current. It will come over this pin here. It will go to the center tap, and it will go out over the 2 signal pins into my PSE, and I have my closed loop. Now, there is a parameter or a test condition for the inductance that I mentioned before, and that's the DC bias. Basically, the DC bias is giving me how much of an unbalance I have between this pin here, or this wire here, and this wire here. So basically, it should be around the 3%. So the 350 microhenries, which are defined in the IEEE, they are defined with 8 milliamp DC bias. So when we measure our Lan transformers and we check that we have over 350 microhenries, we also check with 8 milliamp DC bias, so that we are sure that even if we have any unbalances here, the inductance value will not drop so much that it's under the required value. What I want to show you guys here is the difference between an RG45 for a PD and for a PSE. So in this case here, we have a diode bridge, and the diode bridge will take care that, however I connect my PSE, I am for sure having the plus and the minus on pin 9 and pin 10. So generally speaking, the PSE will be from one manufacturer and the PD can be from another manufacturer. So if we don't have the diode bridge, it can happen that if we have two different manufacturers for PSE and PD, that I burn down my PD because I'm connecting, because here the PSE maybe is giving me the plus on the 10 on the pin 10 and the minus on the pin 9. So basically what I'm doing is I'm introducing the DC current over pin 10, whereas my PD is saying, oh, I want to send back the DC current here. So that can, bring some problems. So if you want to have an RG45 for a PD, make sure that you have an RG45 either with a diode bridge integrated already in it, or please make sure that you have a diode bridge on your board before the transformer. At least not before the transformer, but at least before these pins here that go into your PD, to make sure you always have plus and minus in the correct position. Here we can also see there are some slight differences between the schematics. If I'm having an RG45 or a transformer, in this case it applies rather for an RG45 for a PD or for a power source equipment. As we can see here, we have 4 different pins here for the PoE. So basically what I'm doing is over J1, 2, 3, 6, 4, 5, 7, 8, I'm putting in my DC current, and somehow it's coming out here, and then it's going up to pin 13, 14, 15, and 16. And as you can see, we have no diode bridge here. So this here is a clear example for a RG45 for a power sourcing equipment. If you use it for a PD, as I said, you need to make sure that you have here the diode bridge. So you can use it for a PD as well, but make sure you have the diode bridge here. In this case here, because we have the diode bridge here, it is for a power device. I mentioned before the HPLE aspect, high performance low EMI. In this case here, this guy here is not HPLE, and this guy here is an HPLE. What is the difference? If you can see here, I've marked it in green, we have an extra common mode choke. Now, what I have here is that any common mode signals that are probably in my board will not be transferred, or the common mode choke on this side will make sure that you're not passing on to the other side. And here we also have the RG45 with the common mode choke on the cable side, which will also make sure that the common mode signals will not pass over. Here on this slide, you can see a very clear measurement of how a non-HPLE curve looks like and how an HPLE curve looks like. So we have had some customers that are having EMI issues, and by adding an extra common mode choke, they can see this kind of improvement. So, if there's any kind of, for example, here at 125 megahertz, if you're having any spikes at the fundamental frequencies, you can, put those down with an extra common mode choke. And instead of having an extra common mode choke integrated or placed on your PCB, which will take up, a little bit of space and requires a little bit more of design, we have transformers that, include already the 2 common mode chokes on both sides of the transformers. This question pops up also very often. So we have voltage versus current-driven PHY chips. So we can find on the market both voltage-driven PHYs and current-driven PHYs. And you need to bear in mind that the transformer you're going to use also needs to be, applicable for voltage or current. So if you see here, this is a clear example for a voltage driven PHY chip, because the center tap here is separated. So we cannot have the center taps here of the transformer all put together if we have a voltage driven PHY chip. If we have a current-driven PHY chip, what we cannot have is the common mode choke on the PHY chip side. The reason being is that the current driving or supplying the PHY chip might saturate the core of the common mode choke, and the common mode choke will not do its function anymore. Here I have also a few examples for you guys. So here, voltage driven, yes, because I have here all my center taps are separated. So I can go ahead and say, okay, I want to have a capacitor here connected to the ground, or I can have an RG45, which already includes these capacitors for me. So you can see here, all of them, they are together, but they have the capacitor, and all of them are connected to signal ground. In this case here, these are for current driven. It could also be used for a voltage driven in this case here, because we don't have a common mode choke on this side, and we also have the center tap separated. And on this side here, we have everything connected, all the center taps connected to one another. So I could not use this one for a voltage driven PHY chip. Now, I have heard that some customers do actually use this kind of layout for a voltage driven PHY chip. But as I said, this is the information and the knowledge that I have, that it should not be used. But in the end, we need to look, or you guys need to look, when you are designing an Ethernet application, you need to go up and look up the datasheet of the PHY chip. And there is a section always with magnetics, and it will be shown how you need to connect your magnetics. I would like to show you now the development that we've been doing in the past years and what we have planned for the next years. In 2018, we had the, before 2018, we had the idea of coming up with a THT reflow version of the RG45. So as you know, the THT are soldered with wave soldering, but many of the components on a PCB board are soldered in reflow. So we had a lot of customers that would, they were asking for a THT version which could be sold per reflow. So we came up with the design. We did a few developments there, and analysis and tests and so on. And we came up in 2018 with one of those RG45s. I will show you later on a little bit more details into it. We also came up with a Lan Eq. So Lan Eq stands for automated quality. In this case, we have LAN transformers, which are fully automatically produced. They are composed of LAN transformer and common mode choke. And as I said, they are fully automated. In 2019, some of our customers were asking us, okay, if you have a Lan Eq, which has a fully automated produced transformer inside, can we have those transformers independently, because we have a few place constraints on the PCB board, and we would like to have the flexibility of placing those transformers individually on the PCB board. So we said, yeah, why not? We can offer you guys those. So since 2019, we have the STSTs, and I will give you also a small insight into those transformers in a few seconds. In 2020, we came up with a single pair Ethernet. This is a technology which is booming. I'm sure that many of you know single pair Ethernet, have heard of it, or are even involved in development of single pair Ethernet designs. Here we are working very closely with IC partners to develop the transformers and the different components, such as capacitors or TVS diodes or common mode chokes, that come into this kind of applications. And basically what we have is our STST, which is also suitable for single pair Ethernet applications or designs. This year, we are very proud to be able to announce that we have the new Lan MX on boards. Those are connectors for the industry. They are IP67 certified. So in case you have any, dust environments or humid or, wet environments, you can use these Lan MX, and they have integrated transformer and common mode choke and BOS termination inside. We are also starting to offer our BMS transformers, so for battery management systems. And we are looking forward to offer a filtered SPE connector, single pair Ethernet connector, with the single pair wire connector. And since for single pair Ethernet currently we only can offer for 10 and 100 base T1, we're also developing the 1000 base T1 L transformer. In terms of sexy articles, this one has nothing to do with Ethernet, but I just wanted to mention if that's okay for you guys. We have an EPLE connector. That's a filtered USB connector, which contains the ESD protection and a ferrite bead and so on and so forth inside. There's no other competitor on the market that has this. So if you are looking for something like this, just give a heads up, and we will be more than happy to support you guys. As I mentioned before, going back to the Ethernet applications, we have some transformers that are UL 60601 certified. So we have from basic isolation to reinforced isolation, from 1.5 to 4 kV, even 6 kV isolation, with the required creepage and clearance distances for 1 or 2 MOPP applications. So basically, these guys, the difference is that we need to have some space inside. So the cores need to be arranged in a specific way inside the housing. The housing also, of course, needs to be a little bit bigger than the non-medical, I would say, transformers. Reason for that is the creepage and clearance distance that we need to fulfill. And also the type of wire used. So the wire used in current LAN transformers is an enameled wire, and enameled wire is not seen as an insulation wire for IEC 60601. So we need to have either fully insulated wire or basic isolation wire or triple insulated wire. HD-based is a technology from Valens. I don't know if you guys know this. It is a technology which will basically allow to transfer audio and video in high quality, 4K 60, Ethernet power control signals and USB signals all over the same Ethernet cable. So either a Cat6 or a Cat7 with 100 meters. So for this one, we've also been working very closely with Valens to develop some of those transformers that come into the HD-based application devices. And we have a whole load of transformers that do fit into this application. So if you ever go into one of these designs, just be aware that we have those, and that we also have a very close cooperation with Valens. So yeah, they test our transformers and give us feedback, and we improve them back, and so on and so forth, until we have the best solution that we can offer our and their customers. As I mentioned before, here you can see the inside of a Lan Eq. This is the 100 base T version, and this is the 1000 base T version. So you can see we have 4 STs inside and 4 common mode chokes inside. The benefit of this is, as I said, it is fully automatically produced. What is the benefit of 100% automation? The main benefit is that the difference between two produced samples is very small. So the insertion loss, the return loss, the inductance, and so on and so forth. So all the parameters of the transformer are very, very tight. Whereas for the current LAN transformers, there is some level of manual work. And of course, we're not robots, so maybe the cores are placed slightly differently or with another angle, or by winding, the windings are not so equally wounded on the core. So all of this does affect the performance. Not that the performance is bad. I mean, we've been selling those for a long time, and nobody has had any issues. But as I said, this is one of the main benefits of the Lan Eq. We have a metal case on top. This is a question that comes up quite often. Is the metal case there for EMI purposes? Actually, right now it is not there for EMI purposes because it is not connected to ground. So we don't have any ground plane on the board. The only ground contacts that we have are these two here. So these two are actually connected to the housing. And any, of course, any EMI coming to the to the housing will be directly put to ground here over these two pins. But what we are doing in development is a LAN transformer, so Lan Eq, which has a ground plane, which has more connection to the ground, so that we can better, so that we can improve the EMI performance of those. Also to mention here the half vias that we have here as pins. So basically, this part here of the pad that you have will be soldered onto the PCB. But if we don't have these half vias here, you're not going to be able to check the soldering joints with an AOI machine. Instead, here with the half vias, you can see you can use an AOI inspection, and you can see if your solder joint is good or not, because the solder will actually flow up here a little bit into the half via. For SCSTs, as I said before, we have a better RF parameter performance because it is automatically wounded. The inductance value that we have is over 350, so we have a whole bunch of transformers with over 350 and below 350. So there are customers that don't need the 350 microhenries, but I know that competitor does not have over 350, and many customers do actually have interest on over 350 microhenries inductance values. Something that also outstands here for this series as opposed to competitor is that we actually guarantee that we have the 1.5 kV isolation on these guys here. And I have not seen any other information on that from competitor side. So here you can actually see, okay, we have an SCST, which can be used for LAN transformers. It can also be used for HDBaseT, so we have those as well. Or for single pair Ethernet, if we have less turns, as we have for LAN. Less turns means lower inductance. And if we have a different turns ratio, which we also have, we can use the STST either for sensor applications. We have two transformers that are used for the sensors in the park systems, so for long distances or short distances. And even we can also use them for G.fast. So G.fast is also a technology that is, being used in bringing internet to the home, for example. Going into the RG45 THR version, as you can see here, we have had to do a few changes to the common RG45s, THTs. Here, basically, what we've done is we've changed the plastic of the corpse of the RG45. It is an LCP plastic. So before it was an DAP, and now it's an LCP plastic. And also the LEDs are different. So the LEDs, they are light pipes. LEDs are SMD mounted on the PCB board inside the RG45, and the light will be transferred over the light pipe all the way through to the front side of the RG45. What we have also done here, because we were seeing that from competitor, there were no good soldering results in the pins here, especially. We created a standoff here with 1.6 millimeters so that the airflow in the reflow oven actually gets into these pins here, melts the solder paste, and has a good soldering result. The Lan 12 here, as I said before, it is IP67 certified. It can also be soldered by TH reflow. It is 802.3 compliant. It has the integrated magnetics inside as well, so you can save all the fuss of designing and the layout of the Ethernet interface. And it is also very stable for vibration, so this is especially interesting for the industry. Finally, I would also like to mention that on our website, we have different simulation models. So we have P-Spice models, S-parameters, LT-Spice, and we also have our Red Expert tool. If you want to go ahead and have a look at those, you will find many of the transformers that we have in our portfolio. But please be aware that not all of the transformers are on Red Expert. So if you don't find the correct transformer or the transformer you need, just give a heads up and we will be looking for the correct transformer for you guys. The reason being is that we have over 150 article numbers for the discrete series and over 200 for the RG45s. So I think we do you a favor in not showing you all of the LAN transformers that we have in our portfolio, in our system, in our database. So here again, you can see that we have the whole simulation, P-Spice, LT-Spice models, and also S parameters for most of our transformers. And if we don't have them, we will do them for you. So at this point, I would like to say thank you very much for joining today. Thank you very much also for listening to my presentation. And Amelia, I give you the word back again. And if there are any questions, I am more than happy to answer them.
Thank you so much for presenting. It looks like we did have a few questions coming in at the end. I will go ahead and sort through them. We have a few. All right, here is our first question. We have seen transformers for power over Ethernet applications. Can every transformer be used for PoE applications? And second part of this, is PoE supported on both sides of the transformer?
Okay, thank you very much for the question. That is a very interesting question because I actually do get that from customers many times. I will go back to the PoE here, for example, let's fix here. So the first question was, if every transformer can be used for PoE? Unfortunately not. We need to differentiate between PoE transformers and non-PoE LAN transformers. The reason being is the materials of which the LAN transformer consists of are either PoE capable or not. So basically the core can be saturated because basically PoE current is a DC current, which can saturate my core, my common mode choke core. And my transformer core will also be saturated, which will make that the inductance value of the transformer will drop. So if we have a non-PoE transformer and we use PoE on a transformer like this, it can happen on one side that I have no common mode rejection, on the other side that I don't have the inductance value that my PHY chip needs to work. And the second aspect of it is that the wire is different. So you can imagine if we apply, let's say, 1 amp of DC current on a transformer which is not designed for PoE, the wire will literally burn. So yeah. The second part of the question, if I recall correctly, was if we can switch, if we can turn around the transformer. Is that right, Amelia?
Yes. Is it supported on both sides of the transformer? Is PoE supported on both sides?
Right, great. Okay, so yes and no. If I have a 2-wire common mode choke on the cable side, I will not be able to use PoE on there, unless the common mode choke is designed for PoE. But generally speaking, it is not. If on the datasheet it's mentioned that it is a PoE transformer and the common mode choke is on the cable side, then everything's fine. But basically what we have here is a 3 common mode choke here on the screen, on the picture. The good thing here with the 3-wire common mode choke is that my DC current, as we see here, is coming in through J1 and J2. It's adding up and it's coming in the other direction out of this pin here, pin 7. So I have, let's say, 300 milliamps here and 300 milliamps there to have 600 milliamps. So I have 300 and 300 coming in, so 600 coming in, 600 coming out, so it cancels. If I have a 2 common mode choke, it will not cancel because I have my 300 coming in here, 300 coming in there, which will saturate my core. So this is why we need to be careful. If we have a transformer, let me check for one of those schematics that I had before. If I have this transformer like this, for example, imagine this one here was not a 3 common mode choke, 3-wire, it's only a 2-wire. And I want to put it on this side here on the cable, it will probably not work. So don't go ahead and just, switch 180 degrees your LAN transformer on the PCB board because it might probably not work as it should.
Okay, thank you. Our next question, now you had mentioned that not every transformer can be used for PoE applications. So this next question is great. We want to make sure that we cover it. What are the differences between a non-PoE transformer and a PoE transformer?
Okay, so as I said before, basically the differences are in the core material and also on the wire. So the wire will become thicker. We can also see this here on one of the first slides that I showed you guys. So you can see here, where am I? Here am I. You can see, oh, my computer is here. So on one side here, this is a PoE plus transformer. You can see the core, as opposed to this core here, is much thicker. And you can also see the wire is much thicker. So maybe the picture is not so sharp, but you can see the wire here is much thicker as the wire here. Okay, so as I said, basically these two, one, the wire is thicker, two, the core is made of a different material or with a higher permeability.
Okay, thank you for those definitions. And this is this is an interesting one. What are the effects or maybe even the consequences of using a land transformer over that defined operating temperature range?
Oh yeah, that's also a very typical question that we get. So in our datasheet, we specify an operating temperature range. I think I have it also here on the, yes, it's here. So operating temperature for this specific transformer here is from 0 to 70 degrees. Now, this operating temperature already includes the temperature rise of the transformer. So if we have a PoE transformer, when PoE is flowing, it will become hot. Now, if we have an environment of 70 degrees, I should not be using that transformer for with PoE because I already have my 70 degrees in my ambient temperature. So if my transformer is going to become hotter, I can have effects on the inductance, since if the temperature rises, the inductance will go down. So the answer is actually no, we cannot use transformers outside of the operating temperature. I mean, it's not that, you know, it will burn or something really catastrophic will happen, but probably the performance that you're looking for will not be there, you know. So in such case, you should be looking at a transformer for PoE applications, which goes from -40 to 85 degrees, even to 125, which we also have in our portfolio. But if you have, let's say, like 35 degrees C ambient temperature, then it should be okay if you use a 0 to 70.
Okay, thank you. A few more questions here. What is the proper way to connect the transformer? Does the common mode choke face the device or the network?
So as I said before, it depends. So basically, I cannot give you 100% correct answer because each PHY manufacturer will define how the LAN transformer needs to be connected. So if you buy a PHY chip from, I don't know, Analog Devices, for example, they will have on the datasheet a section called magnetics, and here you will see what you have, what transformer you have to use. So it depends actually, you know, and it makes no big difference if you connect the common mode choke on the cable side or on the data side. The main difference comes when you have PoE, as I said before. So if you have PoE, you're very probably not going to have a common mode choke on the cable side because it might saturate and it might not work as it should. And yeah, so basically no clear answer here. I hope that's okay for you, but you know, in the end, you need to have a look into the datasheet and see what the PHY chip manufacturer is recommending to do.
Absolutely. And our final question here, we do have a few coming in that are very application specific. And I just want to comment that we will be reaching out to those attendees directly just to make sure that we can really dive deep into those applications and answer to the best of our abilities. Our final question, what application is used for single pair Ethernet?
I'm not sure if I really understand the question. So basically, single pair Ethernet is, as I said before, the Ethernet cable has 4 pairs, so 8 wires, and the single pair Ethernet has only 1 pair. So we only have 2 wires. We don't have 8 wires as we have for the normal Ethernet connections. One of the main applications is in automotive. So in cars, not automotive in terms of, you know, in the motor or something like this, but in the how do you say, in the displays used inside the car, or for example connecting the camera to the display or the different sensors. So basically connecting all of these together, if we were to use a normal Ethernet with 8 wires inside, you can imagine on one side the price is perhaps a little bit more. Second, especially, and this is the main reason, is the weight of the cable. So we can have a lot of meters. I mean, you cannot imagine how many meters of cable we can have in the car, even though maybe the car is 3-4 meters long. We can have a lot of cable there. So using a single pair cable is a very big benefit in this case. So that's one of the applications. I know as well some applications in the industry. So for robots, these also use single pair Ethernet. So we also have some customers in the industry that use our ST transformer. Yeah.
Thank you. Absolutely. And as these applications get smaller, so do our cables. Like you mentioned, the robotics, the smaller the cable, the less room it's going to take up and the lighter your application can become. Hero, thank you very much for presenting today's webinar.
No worries, my pleasure. I hope it was of use for everybody. In case there are any open questions, Amelia, you know, we can have a chat later on and you can forward me those questions and I will do the best I can do to answer those.
Yes, absolutely. And for our attendees, if you have a question that you think of a little bit later, simply reply to our follow-up email. You will be receiving the video on demand as well as the presentation within the next 24 to 48 hours. Of course, don't forget to register for our next webinar coming up next week on the 12th. Chum Sum will present We Cut the Cord, Wireless Power Transfer. Register online at www.we-online.com/webinars. I'm Amelia Thompson. Thank you for joining us for today's Wurth Electronic webinar. Have a great afternoon.